Students, already we have seen drugs coming under 4 aminoquinolones and 8 aminoquinolones. Now we'll see the mechanism of action of these two. We'll see one by one. Now we'll see the mechanism of action of 4 aminoquinolones. The mosquito, after biting the human beings, it utilizes the host hemoglobin as a source of amino acid and forms a product called as hematin or free heme, otherwise FP9, otherwise ferriprotoporphyrin 9. This is toxic to the parasite and not toxic to the host, and this one undergoes metabolism to form hemozoin, that is non toxic to the parasite. So this is a general reaction occurring in the mosquito. Okay. Now if you are giving the drug that is 4 aminoquinolones, that 4 aminoquinolones are binding with this hematin to form a drug heme complex. Because of this complex formation, it would not be metabolized to form hemozoin. So if it is not converted into hemozoin, we are getting only there may be only hematin. So already we have seen hematin, no, that is toxic to the parasite and that causes death of the parasite. So that is the general mechanism of action of 4 aminoquinolones. We'll see that. The host is having hemoglobin, no, so that is transported into the food vacuoles or the plasmodium, and that one undergoes digestion and forms a product that is acting as a source of amino acid. What is the product? The product is called free heme or hematin or ferriprotoporphyrin 9, and that one is toxic to the plasmodium. So within the plasmodium vacuole, the organism, no, that is capable of converting hematin into hemozoin. That hemozoin is non-toxic, and what is hemozoin? That is the polymeric form of hematin. This hemozoin is insoluble and chemically inert, and it is not having any biological effect on the plasmodium. So this is the general action. Now if the 4 aminoquinolones are given, that one is binding with hematin to form a drug heme complex. Here how it is binding? Here the quinoline ring, no, that pi bonds with the porphyrin nucleus, and this complex blocks the further biocrystallization. So there may be only free hematin, that is toxic to the parasite and causes death of the plasmodium. So that is the mechanism of action of 4 aminoquinolones. Now we will see the mechanism of action of 8 aminoquinolones. This 8 aminoquinolones undergo auto-oxidation to form reactive oxygen species. They are otherwise called as cell destructive oxidants. And the examples for reactive oxygen species may be hydrogen peroxide, hydroxy radical and superoxide radical anion. And that leads to oxidative damage to the critical cellular components. So what is that? It undergoes oxidation to form reactive oxygen species. The examples for that would be hydrogen peroxide, hydroxy radical and superoxide radical anion, and that causes oxidative damage to the critical cellular components and leads to cell death. Now we will see the formation of reactive oxygen species. In the case of 8 aminoquinolones, it is having amino group in 8th position. So that amino group undergoes oxidation, that will be converted into nitro group. So here we are getting aryl nitro group. That one takes up electron to form aryl nitro radical anion. This one takes up oxygen to form a superoxide radical anion. So O2 with radical and anion, that's why it is called as superoxide radical anion, and this would be removed. So aryl nitro group would be removed. Now this superoxide radical anion would be added with the 2 hydrogen atoms. So because of that addition, what happens here? We are getting hydrogen peroxide. This hydrogen peroxide, that is H2O2, that would be that undergoes homolytic cleavage. We are getting hydroxy radical, 2 molecules of hydroxy radical. So these 3 are the examples for reactive oxygen species. They are superoxide radical anion, hydrogen peroxide and hydroxy radical. So what is the action of these 3 reactive oxygen species? They cause oxidative damage to the critical cellular components and causes cell death. So that is the mechanism of action of 8 aminoquinolones.